Hi everyone. Today we're going to be learning about our solar system. So if you need me, please notice that I've included my email address on the screen again, rcrawford@jcpsmail.org. It's definitely the best way to get a hold of me. If you haven't already, please take a second, pause the video, gather your materials. You'll need a pencil, your science notebook, and some color pencils. Let's jump right in. So let's start out with a bell ringer. We're going to have some review questions. Okay? Our first question is, what causes Earth's seasons? Put this simply. In other words, what are the reasons for the seasons? Pause the video, think about your answer. Once you're ready to answer, you can restart the video and see if you're right. I hope that you ended up thinking that the reason for the seasons is the tilt of Earth on its axis. Remember, we said no tilt of the axis, no seasons. So the tilt of Earth on its axis is the reason for the seasons. Let's look at our next question. So here's our next question. Question 2. When it is summer in the southern hemisphere, it is what season in the northern hemisphere? Pause your video. Once you think you have your answer, you can go ahead. I hope you said winter. So remember, our seasons are reversed in the hemisphere. So while it is summer in the southern hemisphere, it's going to be winter in the northern hemisphere. We're getting ready to enter summer right now in our northern hemisphere, which means that in the southern hemisphere, below the equator, like in South America, they're getting ready for winter. All right, here's our last question. True seasons, which by that I mean hot summers and cold winters, mostly occur in which climate zone? So remember, our climate zones are things like tropical, things like temperate, or polar. So which one of those climate zones mostly have true seasons? Pause the video. When you think you know your answer, go ahead. True seasons in which climate zone? Hopefully you remember that that is temperate. When we looked at Reykjavik, which was near the poles, remember our high temperature through the year, highest average temperature was like 54 degrees. It's not really hot summers. But when we looked near the poles, near the equator, when we looked at Bogota, Colombia, we found that they didn't have much seasonal change at all. That they had mostly a steady temperature of about 68 degrees all throughout the year. So we only really get our change of seasons, true seasons, in the temperate climate zone. So fairly short lesson today, but let's take a look at our objectives. So by the end of this video, you should be able to list 6 different types of objects that are found in our solar system. In addition, you should be able to list 3 ways that the motions of the planets are similar to one another. And finally, I need you to be able to explain what the most abundant thing is in our solar system. And hopefully you'll be able to explain how many models of our solar system are misleading. Let's jump right in. Okay, so stop and think. Before you go any further, I want you to go ahead and see if you can answer this question. I want you to go ahead and name as many different types of natural objects in our solar system as you can think of. You can write this in the margin of your notebook if it's helpful, or you can do this in your mind. Please don't include things that orbit Earth. Please notice that it says natural, so I don't want man-made things. I want things, objects that are out in space that are part of our solar system. Go ahead and pause the video. Once you have your answers, go ahead and hit play again. Okay, so how many different types of things were you able to name in our solar system? First off, let's go ahead and agree what I mean by solar system. A solar system is really just a star and all the stuff that's going around it. And we have lots of different kinds of stuff. So here's our star. For our solar system, we just call it the sun. And then we have these things that have their own individual names. We have some more stuff here. So let's take a look. Let's see what we included on our list. So a solar system includes things like we have a star. Okay, so every solar system, sol actually means star. Every solar system has to have a star. We have planets. So Some solar systems, not all, but many, seem to have planets, these other objects that orbit around the star. And here we have some planets. We have 4 planets here, and then we have 4 planets out here. So we have a star, planets. What other types of things? Moons. So we look just here, we just studied Earth's moon. We can see that little object above Earth's moon, excuse me, above the Earth. That is Earth's moon. And some of the other planets have moons as well. Hopefully some of you were able to remember asteroids. So here we can see these smaller objects called asteroids. These are also orbiting around our sun. They're also part of our solar system. Comets. Here's a comet. Here's a comet. Some of you may know what those are, some of you may not. Some of you may have tried to name something called dwarf planets. Um, Here we see a few dwarf planets. I've got a dwarf planet called Eris and Pluto, and this is called Maki Maki, which is a Hawaiian name. Here we have another dwarf planet called Ceres. So we have these things called dwarf planets that are part of our solar system as well. And finally, we have meteoroids. Now, meteoroids aren't shown on here, and hopefully it'll become clear why they're not shown on here as we continue talking about stuff that's in our solar system. So in a solar system, in ours, we have a star, our sun, we have planets, we have moons that orbit around those planets, we have hunks of rock called asteroids, we have comets, dwarf planets, and meteoroids. If you were able to get some of those on your list as well. This is a diagram that we've seen before, but I want to quickly review it. I want to give you the quick reminder that by far our sun, the star in our solar system, is the biggest thing here. So in our neighborhood, the sun is it. We can see the planets, which in our last diagram looked considerably big. We can see the planets compared to the sun are completely dwarfed. This is a scale model that shows us the relative sizes of these objects compared to one another, and the sun is ginormous. Now, some of you hopefully are no longer thinking this, but some of you may be thinking, but wait, our sun is a star. How can that be? When I look at the stars at night, they're much smaller. I just need to remind you that they look different because our sun is much closer to us. So it looks much bigger in the sky. It appears much brighter. You can feel the heat from it because it is much closer. Our sun produces most of the energy in our solar system. Light, heat, other types of energy are produced by our sun, but most of the energy in our solar system is produced by this star. It uses something called thermonuclear fusion. Not that you need to know that, but so our sun is made of gases. Some of you have heard this before. Mostly, our sun contains a gas called hydrogen gas, and our sun isn't a solid, it is not a liquid, and it is not a gas, which is a little strange. Hydrogen is a gas here on Earth, but in our sun, it's a fourth state of matter called plasma. Fourth state of matter called plasma. And our sun, even though we say it's made of hydrogen, which we know is a gas, it's pretty dense. So our sun, if we were to be able to drop it in some water with its density, it would sink. So our sun is the biggest thing in our solar system. Remember, it looks bigger and brighter because it's closer, and it is the major producer of energy in our solar system. All right, so our sun is the biggest thing, and we need to remember that everything orbits around the sun. Okay, so all of the things that we listed, whether we're talking about planets, whether we're talking about asteroids or comets, all of those things, dwarf planets, they all orbit around the sun. They are trapped by the sun's immense gravity. When we look specifically at the planets, and this is a good diagram for this, we can see that the orbits of all the planets are pretty much circular. Okay, now here we have a comet that still has a mostly circular orbit, but notice that it's shown as being different from the orbits of the planets. The orbits of the planets, the path they take is very orderly, almost circular. Not perfect though. All of the planets, I want to point out, orbit in the same direction. Okay, so all of these planets are going to be orbiting around the sun in the same direction. We're not going to have an occasional planet that's going to rotate this way clockwise. They all rotate counterclockwise. Okay? I want you to notice, as we look at this from the side, if we look at the orbits of the planet, they're almost shaped like a disc. So if we look at the path that they take, this is something called the orbital plane. Um, all of the planets orbit in the same plane, and I don't mean like an airplane. I mean as in a dimension or a surface. And finally, when we look at each individual planet, we've talked about the fact that Earth rotates on its axis. Well, all of the planets actually have some rotation on their axis. The sun also rotates on an axis. And interestingly, most, not all, we have one notable exception. Most of these planets rotate on their axis in the same direction as two. So this is three ways that when we look at all the planets, this is three ways that we have some sameness. We find that all the planets behave, their motions behave in about the same way. Wait, what? That's a strange slide. So the point here is when we look at our solar system, most often we're focused on the things that are in it. And we draw things very close together. Because why would we not? We focus on the stuff. But the reality is our solar system is mostly made of empty space. That's actually why we call it space. So our solar system is largely a, a really dark, vast void, meaning there's no matter there. There's not stuff. And this can be a little misleading. So I would say our solar system is mostly filled with empty space. That's because the things in space in our solar system are very, 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 very far apart. So the closest planet to us is Venus, and Venus is still 33 million miles from us. 33 million miles. We're 93 million miles from the sun. If we look at this diagram, we can see that everything appears very close together. Here's the sun, here's Venus, here's our orbit. Looks like it's so close. It's really not. That's a little misleading. So things are very, very far apart. More far apart than I can really describe to you. So we're going to try something to maybe help you understand how vast the distances between things are. So when we look at models like this was the best model that I could find. When we look at a model of our solar system, we would find that really if we're able to see these orbital paths, the distance between things, the things that we would be looking at would have to be incredibly tiny. So there, that little dot, and it's really hard to see above this name that says Uranus, you can see that that's supposed to represent the planet. I can tell you that even at this scale, this is much too big. If we're able to see the orbits of the planets like this, the actual planets themselves would be too small to be seen. But this diagram does a better job. Most diagrams are really misleading. Most diagrams of our solar system tend to have us think that the things are relatively close together. Simply not true. All right, so I have a quick assignment for you today. And our assignment is to make a 3-sentence summary. There is an article that is posted on Google Classroom for today. And all I want you to do is to scan the article. And this is about life in the solar system. That's its title. I want you to not read the text. Only look at the title, the section or paragraph headings, which are those words that are written bigger and in bold, pictures, diagrams. You can also look at bold words and italics words on any highlighting. When you finish, this should just take you a moment. I just want you to flip through the article, just scan it. I want you to tell me what you think the article is going to be about. And to do that, you're going to write a 3-sentence summary that explains what the article is about. Once you have your 3-sentence summary, I want you to type that as a reply to today's post. Okay, so just type your 3-sentence summary, 3 complete sentences, use capitalization and punctuation, and I want that to be a reply to our post that tells us what to do in science today. So if you are using the USB and you don't have access to the internet, I want you to simply write your 3-sentence summary in your notebook. All right, guys, I think that's it for today. So until next time, stay curious.